Alright everyone, we'll be doing haloalkanes and haloarenes in this video. So first you're going to be doing is classification, basic classification, that is number of halogen atoms attached and state of hybridization. In number of halogen atoms attached, we can see there's monohalo, dihalo and polyhalogen compounds. So it's kind of a self-explanatory. Monohalo compounds are compounds that have only one halogen group. Right? So we have taken the first example, that is bromine. So we can say, if we try to do its nomenclature, can we say it's bromoethane, right? Next one is dihalo compounds. Dihalo compounds means there are two halogen compounds, right? Over here we have two types, that is vicinal and geminal. So vicinal is when the particular halogen compound is at two different carbons, whereas geminal is when the halogen compound is at the same carbon. This is geminal. When is that same carbon? This is vicinal. Right? Next one is polyhalogen compounds. Polyhalogen compound means multiple amount of halogen compounds like this. I can have carbon chains and n number of halogen compounds attached to the carbon chain. Alright. Now talking about our halogen series, we have fluorine, chlorine, bromine and iodine. Now fluorine is very explosive. Right? So we don't use fluorine for a lot of reactions. And iodine is very less reactive. So we have to find different ways for using them, which we'll see later in the chapter. Next one is chlorine and bromine. They are mostly used for all these reactions, and these are two very important compounds. We'll be seeing a lot more. Now, state of hybridization. There are two types of hybridization, that is sp3 and sp2. Now, if you don't know what hybridization is, let's just recap. For example, if you have a carbon chain like CH3, CH2, Br. Okay. Now, what is the hybridization of the alpha carbon? Alpha carbon is the carbon that is attached to the halogen compound or any functional group, right? This is alpha carbon, this is beta carbon, right? So the carbon attached to the alpha carbon is beta carbon. So if I'm trying to find out the hybridization of this alpha carbon, how will I find it? The C, H, H, Br, and then CH3. So every single bond has a sigma bond. Double bond has a sigma and a pi bond, and triple bond has sigma and two pi bonds. Alright? Clear? So there are 4 single bonds over here. So what is the hybridization over here? sp3. 4 single bonds, 4 sigma bonds is equals to sp3 hybridization. 3 sigma bonds is equals to sp2 hybridization. 2 sigma bonds is equals to sp hybridization. Alright, clear? Now again, what is sp2 hybridization? For example, I have CH2 double bond CH Br like this. So what is the hybridization over here? If I take this and expand it, CH2 double bond CH and Br. This 3 sigma and 1 pi, right? Double bond has sigma and pi. So the hybridization is sp2. Alright, clear? Talking about alkyl halides, now first one, primary alkyl halides. So over here, the carbon carrying halogen is attached to one carbon. Okay, that means CH3, CH2, Cl. Basic example, one carbon. Alright, secondary is carbon carrying halogen is attached to two carbons like C, H3, right? So this alpha carbon is attached to two other carbons. That is a secondary. Over here, alpha carbon is attached to one other carbon. Tertiary is when alpha carbon is attached to 3 other carbons, right? Is it clear? When the alpha carbon. So again, just to be clear, this is what beta 1 carbon, beta 2 carbon. This is just a beta carbon, beta 1, beta 2, beta 3. Alright, clear? So you know what alpha and beta carbons are? Again, I'll repeat it. Alpha carbons are carbons that are attached to the halogen group or any functional group. Clear? Now talking about benzyl halide. This is called the benzyl group, right? This is a benzyl group. So any halide attached to the benzyl group is a benzyl halide, right? If I take chlorine here, this is benzyl chloride. Alright. Now for example, if I take an alcoholic group here, what is it called? Benzyl alcohol. Alright. If I take an amine group here, what is it called? It's called benzylamine. Alright, clear? Now moving to allylic halide. In allylic halide, allylic halides are halides where alpha carbon is sp3 hybridized and beta carbon is sp2 hybridized. Just think for a second, what does it mean? It means that there's a double bond somewhere, there's a single bond somewhere, and there's a halogen group. Alright? So, for example, I have this CH2Cl. This is my alpha carbon. It's supposed to be sp3 hybridized. It is sp3 hybridized. Right? You can see. Now, I'm putting another group here, CH. A double bond here, and CH2. Clear? This is my beta carbon. This is my gamma carbon. Right? We have alpha, beta, gamma. Alright? We know that. So, gamma is after beta. So you can see this is sp2 hybridized. This is an allylic halide. Clear? This is an allylic halide. Okay. Now going to sp2 hybridization. There is aryl halides, there's vinyl halides. Aryl halides are when the particular halogen compound is directly attached to the benzene ring, like chlorobenzene. This is called chlorobenzene. This is called bromobenzene, or iodobenzene. Alright, clear? Now again, just for basic knowledge, people who are very new to chemistry, writing benzene structure like this and this, both of them are correct. Both of them are correct. You can write it in this way or that way. Alright, now vinyl is when the particular halogen compound is attached to an sp2 hybridized carbon. Alright, it could be like this also, CH3, CH2, 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 CH double bond CHCl. This is also a vinyl halide. Alright, it is basically when a particular halogen compound is attached to sp2 hybridized carbon. Over here also, that is in the sp2 hybridized carbon in chain. This is in chain. This is in ring structure. Benzene ring basically. Alright, clear. Okay, thank you. We'll be continuing with the next part in the next video. Please keep watching, subscribe to my YouTube channel.